This is one thing I'm going to have to sort out. Remember, this collar was broken, aluminium's broken through. That goes onto those 4 studs and retains the bearing in there. And there's also this part here was fitted in to the centre. I don't think that's original, because when you try it on the shaft, it's piss wobbly slack. And I would expect that to be a good fit in there. With a little groove in, like it, I don't know, that's had some sort of a packet of grease to keep the oil in, I'm not quite sure. But I don't think that is original. This might weld. There again, it might not. I think what I'll do is I'll put it on here, figure it out and try and weld it. If it'll weld, it'll weld. If it won't, I'll have to make a one. I think I've got a bit of aluminium plate. It's thick enough to get it out of. But I would rather just repair this one. It's been broken for a long time. Right, so that goes on there. Like that, because I did mark it to get it back in the same place. So it does sort of, or it will fit on there. Like that. So if I veer that out and I'll try and weld it when it's fastened onto there, it's going to keep it nice and flat and square. And see if it doesn't weld, I'll just make another one. And then this centre bore with that, I need to sort something better than that out. That's just not right. As that runs on the end of there like that. And this end is inside the crankcase with splash oil. And that was the bearing track that was actually inside there. I'm not quite sure how I managed to get its way into there. But when I put this back together, I'll just put a little bit of Loctite on the bearing track and that'll stop it from moving. I'm looking at this beautiful bronze housing here, and you can see some rough bastard's been on there with a screwdriver, and it's actually lifted that face there. I think it's only the one. I'll just carefully dress that up with a file. Other way is to take all the studs out and put it in the lathe and just flash that face, but I don't think it needs to be anything as drastic as that. You can see where it's been hammered, screwdriver in there, and it's actually lifted that little face there, which will prevent everything from going down. That's the one there as well. Little lip there, all you've got to be taken off. Nice flat face to start with. See, it's catching the little raised bits on there. Right, so this one here is the one that's got the most damage on it. These ones are all okay, just that little bit there. That looks good. Right, so we'll settle for that. I'm going to bolt the aluminium down onto this and then weld it clamped onto there. Then hopefully it'll, well, we'll wait and see. It's definitely the way it goes because I did mark it before it come to bits. Right, we'll tighten that down, and like I say, I'll lay this right out. I'm not just going to stick it together. It'll either repair properly or it'll get a new one made. And these holes have been slotted anyway, so it's obviously a little bit of a Heath Robinson type affair. And I'll probably bore this hole bigger, then make a new sleeve to go through. And these things were never oil tight. I think they work on the principle that if there was oil leaking out, there was plenty in there. But that fracture mark, that crack is going down, pulling down nice. I've not used that spanner for a long time. 5/16 Whitworth. Until these nuts were pre-war, because during the war they made the nuts smaller, the spanner size smaller to save on material. So I've been told, and it certainly seems a logical thing to do, because that is two sizes of nut with the same thread. Oh dear me, Johnny. Right. That looks good in there. Let's see. I've decided just to make a new plate instead of pissed about trying to weld it up. Unfortunately, the bit of aluminium I had wasn't quite wide enough, but Dave wanted to play with our new Artec welding helmet, so she sat and ran bead after bead on the end of there and put about 15mm on the end of it. I can skim this flat now, and we'll make one out of there. It's not the tool for aluminium, is it? Right. This should give better results with a bit of luck. Right, we'll definitely settle for that, definitely. Right, I've got one face nice and flat and it's parallel to that face. The easy way to set this up in the chuck is to machine that face without using the clock gauge. I've got a tool holder on here, a nice big flat one. If I set that up against the face on that chuck like that, that means that that tool holder is now parallel to the face of the chuck. So if we simply put the workpiece in here, I want to try and make sure it's sort of in the middle, so I'm going to looking at the gaps on these jaws. Wants to come across this way a little bit. That's better. Right, so that's kind of in the middle. Now, what I can do is bring this in. We want it offsetting a little bit. Okay, so if I touch that against that tool like that, it can be nothing else other than parallel to the chuck. Right, now we can tighten it up. Right, so if I take a light skim across that face, you'll feel it should be parallel to that face there. Right, for a quick, rough and ready way to set up something in a chuck, that certainly works. There's a fair amount to come off here. It's not perfect, but it certainly isn't a kick in the arse off. It's a nice solid weld, build up as well. You can see where the weld is there. He's made a good job of that. Next we machine a shoulder that pushes onto the bearing. The shoulder's 1.6mm deep. I've got that set in the exact centre, so if I wind the cross slide out, half the diameter of that bearing plus a little bit, it's going to give us a good start to machine the recess into. I want some mark just to make sure I'm not going to go too small. That's good, that's 0.5mm bigger all round. So we can machine down to that line. And we know we're not going to go far wrong. We'll set a 0 on the dial at that line. Right, 1.6 is the depth we need. Not cut anywhere near as nice as the round tool was. Just make sure we've got enough to take off just to finish that. If we measure the bearing like that, and simply 0, and we'll measure this. We need to take off 2.5mm, direct reading. So that's 2.5mm halved. We'll do 1mm first and measure it again. That should take 2mm off it. I've left enough metal on here to do one cut going out of that to finish it off. And so we want 0.34 of it. Right, just under, so it'll actually go inside the bearings, what we need. once again, it's just time to say thanks for watching, thanks for subscribing, and as always, a massive thanks for all the well wishes. Anyway, thanks for watching.